Hello everyone, good evening. I hope I'm pretty much audible as well as visible. Guys, just a quick hi or hello in the chat would be really good if you can just tell me if I'm audible. So I welcome you all in today's discussion, which is data analysis in 3 weeks. That's our playlist, right? And we are pretty much talking about discussions in Seaborn. So we'll be finishing up the Seaborn. I'll be giving you the last set of graphs which we have, and then post that we'll also be seeing what all different hyperparameters which we can give, which the remaining topic we have here, right? So that's pretty much what we have in our discussion. We'll be closing Seaborn today. So if anybody is having any concerns of whatsoever we have discussed so far, guys, this is the time. So do let me know your thoughts, and if you are stuck anywhere, any questions if you have, so just do let me know, right? So we'll try to take that. Cool. So that's pretty much fine. Again, so I'm pretty much going live here. So try to ask questions and try to be as relevant as possible. So we'll try to close the points and we'll try to have the things mentioned in our discussion. So great. So that's pretty much about it. So before starting, and as I've said, so I'm pretty much monitoring my chat. So if anybody is having any concerns to whatsoever we have discussed so far, right? So try to utilize the time and try to ask the question. So I try to answer them to the best of my knowledge. And the questions could be from anywhere. So even if you have questions from, your general questions regarding your topic or anything, whatever you want to discuss. So we can pretty much have it. Okay. So that's about it, and we are live. So you can ask your queries. I'm pretty much monitoring the chat. So let's start, guys. So I'll first introduce myself, and then I proceed with the topic for the day. Right, so my name is Arpit Jain, and I'm a lead data scientist myself. I have been into industry for almost 9 years, into multiple domains, be it finance, be it manufacturing, automobile, cloud, telecommunications. So I've been into multiple fields. So any concerns, any questions regarding any part of your thing, right? So please do let me know, so I can take up your questions. And also I'm a motivational speaker, so I take industry sessions. I talk to students regarding their job, career, placements, and everything. So anything regarding that front as well. So utilize the time, try to have your questions handy, so we can discuss about them as well. Great. So that's pretty much quick intro about myself. So now, without wasting time, let me jump into the content, and then we'll start with our topic for the day, which is Seaborn hyperparameters, and I'll be closing all the remaining graphs which we have for the day. Right. Before that, let me know, guys, if you have any other questions. Just give me a minute, guys. I'm setting this up. Cool. So just let me know if my screen is visible, guys. Great. So I'm pretty much into our content discussion for Seaborn. So yesterday, remember we were talking about box plot and violin plot. So box plot was giving you information regarding the data spread, the data distribution per category. So for all the categories, you were trying to identify how the data is distributed. Likewise, in the violin plot, so we are getting two things. We are also getting the distribution, plus along with that we're getting the density as well, right? So how the data is distributed, and also how the density is. So if there is any particular point where the data is more spread out, and if there are more data points in a particular region, so all of these points are pretty much what we have in terms of the violin plot, right? So I hope you can see here, so we have the wider gaps in this area, so we can definitely assume that the number of data points are pretty much higher in this area. So that's what it says, right? So as I said, any questions in this, guys, all welcome. Please do let me know, okay? Cool. So proceeding further, we discuss about other hyperparameters here. So next we started with the bar plot. We were discussing about how we can identify the a frequency, like kind of a density of my information. So how the data is spread in terms of different categories again. So here it's a categorical to numerical plot. So where we are trying to see how the values are behaving per category. Right? So this is what again we are doing it here. So we have seen that it's again pretty simple, not very tricky here. So the hyperparameter is also pretty simple. So we discussed about some of the complex parameters. We discussed about order, cap size, saturation. So all of this, you can definitely try all of these hyperparameters on your own also. So likewise, we have n number of such hyperparameters available. So everything is having a different definition. And you will be very much getting the logic also. So very much getting the documentation for each of them. Just you have to give shift tab. You'll open up a short documentation. So you can see all the available list of arguments which can be passed here is pretty much available here. And there is a description for all of them also. You can see all the description is pretty much here. So if any concerns, anything, if you don't know, you can always refer the documentation also. Right? So now in this category, we have another plot called as count plot. So this is a special case in bar plot in which the number of observations in each category rather than computing the statistic for a second variable is shown. So here we are actually counting the number of observations per category and we are plotting it here, right? So you can see this in terms of class, which is my x variable here, first, second and third. I'm trying to identify how the data is spread out. So we are trying to see what, so it's like so here I'm only passing an x, I'm not passing x and y. You notice that, right? So I'm just passing an x. So and now what I'm seeing is for each of my subclasses of my x, I'm trying to count the number of observations, right? So if I sum up my first, second and third observation, it should definitely give me the total number of observations, right? So here count plot is giving me the number of count available for each of my such classes in my data set. So that's pretty much what my count plot is doing. Okay. Now here in this count plot, what you are seeing is these individual rectangular boxes, the bars here, right? It is denoting the number of observations, right? So for example, first it is somewhere lying around 200. And then second class lesser than 200, somewhere around 180, 190 I would say. And then third class somewhere around 450, 460, right? But again, still you're trying to kind of, guess the exact number, right? I cannot tell the exact number from this graph. I can only tell the approximation of my values, right? But there is also a possibility that we can directly add the number of such, of the count number. So the number of my observation on top of my bars also. So how we can do that? The same thing. So we're going to just use the count plot, and after the count plot, we're going to pass another function called as bar label. So bar label is available by default if you have this latest version of Seaborn. So we can directly call the bar label function, and under the bar label, we can call the container. So containers is basically the one where it is having before plotting, it actually calculates the number of such values, right, before plotting. So in this container, we already have the data stored. So we were just calling this container. Now if you call it, you can see on top of each of my bars, I'm going to plot 216, 184 and 491. So this is the exact value of my count for each of my classes, also pretty much visible, right? So we can also do that. Now moving ahead, in the count plot itself, again as I said, hue is a pretty omnipresent kind of argument, so we can pass this anywhere. So now in this also I'm passing class is anyway x, and then who is what I'm passing as a hue. So for the hue, I'm having what, man, woman and child. So each of my subcategories, first, second and third, I'm also subcounting exact number of man, women and the child, right? So I'm further subdividing it as a second level of granularity on my data set to find out the number of counts. Even on this, if you want to have, the number of observation to be counted for each of my such categories, I can still do that, right? So same thing. So here the bar label and the container, but yes, in this case, there are multiple such containers, right? So for each of the category, there will be multiple containers. So we can run this on a loop, right? So for example, for container in the containers, I can call each of the container and then print it. So this is how for each of my individual containers, I'll be getting the values, right? So it's very simple again. So again, so I'm also doing the count plot, each of my observation, and each of such different subclasses, I'm also giving exact number of such observations present, okay? Very simple in the count plot also. The next in such category, we have the point plot. So point plot is also very interesting plot, guys, very interesting plot. This basically gives you how the data points are changing from one class to another class. It's giving me the referential kind of a study, right? I'll tell you how it is. So point plot is basically used to show point estimates and confidence intervals using scatter plot glifs, right? So what it is exactly? So point represent an estimate of the central tendency of a numeric variable, right? And also it is more powerful than bar plot by focusing comparison between the different levels. So two things here. So we are getting the confidence interval of every point, and also the relative study between my each classes. So for example, what I just did here, I'm doing a point plot, and here what I'm doing, X as my gender, sex, and the Y as my survived, right? And also I'm passing a US class. So what I'm doing is, for male and female, how many of those have survived, and also I'm trying to subdivide into classes. So first, second, and third, how exactly my classes survival rates are varying under my males and females for each of my classes. That's what I'm trying to plot here, right? So now I can totally see this, the males and the females. So for the first class, the male survival rate started from somewhere around 0.4, and then it extended up to 1 for the female, right? Between the male and the female. Also, the confidence interval, which is this perpendicular line, it shows that the longer the perpendicular line, that means that longer the confidence interval. That means less confident I am, right? So there's a huge variability range. I cannot be pinpointed in terms of the value. It can range in between any of these values, right? So that's what I'm saying. So I'm kind of having a relative study in which I'm comparing how the survival rate is varying from male to female, and that too under different classes, first, second, and third. Cool, that's what we're doing. Okay, so sometimes we're using SNS and sometimes using SB. Okay, so yeah, that's not a problematic thing. So we can actually have anything as a reference. So as I said, so you can simply load the library Seaborn, and you can give any alias you can want to give. So if you want to give, say, SNS or SB, or even if you want to give your own name, you can do that, right? It's just an alias which we generally give. So anything is fine. So I mean there are different times I might have created this code, so that is the reason why you're getting different references. Right? So that's about point plot. So we are trying to give a kind of a referential kind of analysis in which multiple how the data points are varying across different classes. So kind of a referential study here. Okay, that's what we have. Also, now I'm passing as a different data set. So now what I'm doing is in the tips data. So in the tips data, I'm trying to observe. So on each day, how my tip is varying. So we have Thursday, Friday, Saturday, and Sunday, right? So you can see this. This is the average tip values. The central dot here is the central value. So which is the average value. Okay. So 2.8 is the average value on Thursday, and then roughly 2.7 is the average value on Friday, and then Saturday and Sunday, right? So you can see somewhat an increasing trend, right? So somewhat an increasing trend. So every day the average tip value is increasing per day, and definitely there is a substantial increase over the weekend. So Saturdays and Sundays are the days when the tip value is generally higher, right? And also you might have observed the confidence ratio. So we saw a slighter dip, so a very I would say minimal dip on Friday compared to Thursday, right? But what we have here is the confidence interval in this is pretty high. So the confidence interval on Friday is very, very high, right? So you can see this. That means that I'm not very confident. So the value of the tip can range anywhere between 2.1, 2.3 to 3.1, somewhere around that, right? So it has a huge range of values in which it can vary. So that means that I'm saying I'm not very confident, of the data points here. It can vary anywhere between such ranges. So that's pretty much what I'm trying to convince here. Right? Any questions here, guys? Anything which you want to discuss? Anything you are unsure of? Guys, quickly, any questions? Anything which you have and which you want to discuss? Cool, making sense? Right? So similarly, I can do it for anything. So what I've done here is I've added the same data set. So time here. So based on the lunch and dinner, I'm trying to see how my total bill is varying, and that too with smoker category. So whether the smoker and the non-smoker, their bill amounts are changing in terms of time of the day. So whether they are going for lunch or dinner, so how the bill amount is changing. So even that we're trying to observe. So it's giving us, the point plot is giving us a referential kind of a study, right? So referential study in which I'm trying to compare how exactly the data points are varying, right? So again, you can see I've passed an argument called as hue. So hue is kind of an omnipresent. So I've told you this, right? So pretty much possible. Cool. So now with this, we are done with the point estimation or a statistical estimation kind of a graph. So now we'll move towards multi-panel categorical plots, right? So we can have a multi-panel graph. So in which here, so now the categorical data can be easily plotted through point plot, and if more advanced than factor plot, right? So point plot is a very good graph in which we're trying to compare or giving a referential study for a categorical data. But the advanced part of point plot is factor plot. I'll show you what factor plot does. Okay, so factor plot draws a categorical plot on a facet grid, right? So facet grid means here we have an option to split the graph into multiple subgraphs. Okay, so you remember we use the argument call where we are splitting the kind of graph into multiple subgraphs, right? So we were using that particular argument. So likewise, we also have that particular objective, so we can do that in factor plot. I'll show it to you how exactly we can do it. Okay. So now look at this. Right. So now what I'm trying to do is factor plot, right? So I'm plotting a factor plot on terms of my time and y is pulse, kind as hue. Let me go a bit deep here. So now look at this. So in the factor plot itself, I can have an option of kind. So in this kind itself, I can further subdivide my graph. So what kind of graph I want to see as, right? So for example, I want to view this referential study in terms of a violin plot. So I can simply give a violin here as my kind. I can try to see how my data is behaving. At the same time, I can also give kind as box, and I can find out exactly how the data is behaving in terms of box. Okay, there's nothing fancy here, so I'm not going in detail. So here this factor plot is being used only with a simple kind operator. Okay, now I'm moving to actually a facet grid, right? So I told you about the call argument. So you remember this call argument. So now on the same graph, I just added call as diet. Okay, so this call argument is actually not available in what's a point plot. Okay, so if you want to further subdivide my data into multiple subcolumns, right, subgraphs, so I cannot use point plot. So if you want to have a facet grid, if you want to have subgraphs like we did in my previous graphs, right, so using the referential study, so I cannot use point plot there. So point plot does not have any argument call as call. Okay, only factor plot, which is again an advanced part of point plot, has an argument call as call. Okay, so now when we define call on factor plot, this is the place where we can further subdivide my entire graph into two subgraphs. So here you can see this, right? So I'm having two subgraphs now, depending on whatever column I've passed in terms of my call argument, right? So this call argument is not available in point plot. This is the advantage you have in factor plot. You can further subdivide the panel into the row and the column matrices, and you can have the further granularity of my graph. Make sense, guys? Are you able to understand this? Guys, quickly, are you able to understand this? If I'm clear to you, this point is clear, everybody? Okay, so I'm moving ahead. Let's go to the linear. Okay, so now we have another category of plots where we are trying to identify the linear relationships. Okay, so here we are trying to identify the linear relationships in my data. Okay, so to check the linear relationships across multiple variables, we have two plots in Seaborn called as reg plot and lm plot. Okay, so reg plot and the lm plot. These are the again very interesting plots where we are trying to identify the linear relationships between my variables. So what is a linear relationship, right? So remember, we are plotting a scatter plot, right? So I'll just come back to this graph again before I want to show you this. Okay, so something like this, right? So I have this graph, right? So in this graph, I told you, right? So I could sense some sort of positive correlation. So as long as my the variable is increasing, so which is basically my total bill. So as long as my total bill is increasing, my tip is also increasing. So I have a positive correlation, but I don't have any reference line here, right? I don't have any reference lines to compare with, right? So exactly on the same scatter plot, if to add a reference line which shows the trend line for my correlation here, that is what the reg plot and LM plot is talking about, right? The same thing. On top of my scatter plot here, I'm adding a trend line. You can see this trend line, right? It is showing me the trend. It is an upward trend. So as long as my total bill is increasing, my tip is increasing, right? So this is what the reg plot and LM plot does. But again, let's look at them one by one. So reg plot and LM plot, what is the difference? We'll find out that. So reg plot accepts the x and the y variable in a variety of formats, including the simple NumPy arrays, panda series objects, or even the reference variable. So we can pass anything here. Reg plot is very strong. I can even pass a NumPy array in this, right? Now the only difference between reg plot and LM plot is LM plot does everything what reg plot does plus an extension of facet grid. So basically it has an argument, it has an option of an argument call as call. So COL, I can have that argument call in LM plot, but in reg plot the argument call is not available. So the argument call is very strong argument, guys, okay? The call argument is being used to further divide my graph into subplots using the facet grid, right? So this is where I'm trying to utilize the concept of facet grid, multiple subgraphs. So reg plot is not having the feature of the argument call as call, but the LM plot is having the extension of facet grid and having the argument of call, right? So that's what we have here. Cool. So now same thing. So now what I've done is I've loaded the dataset tips here. Now on top of this, I'm plotting SNS.regplot, REGPLOT. X is my total bill. So X is my total bill here. Y is my tip. So I'm trying to analyze my total bill and tip, right? And the data is tips here. So now simple thing. So first it will plot the scatter plot the same way which we have seen earlier. On top of the scatter plot, now it will add the trend line. Okay. So trend line. Cool. So on this trend line, now we can see also one thing here. So can you see the shaded region below and top of the line, right? You can see the shaded region, right? This shaded region is termed as, again, the confidence interval. Now what is confidence interval? It means that this trend line, which is right now in the middle of this shaded region, it can vary from this top of this shaded region to the bottom of this shaded region. So this line can vary anywhere in between this line with the maximum probability of having where it is plotted right now. Okay, but it can still vary from this to this value. Now intuitively, if the shaded region is bigger, that means that I'm saying that I'm very less confident. I don't know where the value is. It can vary in a longer range, right? So having bigger shaded region is bad for your graph. That means that bad means it's not a good trend, right? I'm not very confident. But having the very shorter, very narrower shaded region is actually advantageous, because now in this case I'm saying that I'm very confident. I'm confident because the values is ranging in a very shorter range. So I'm pinpointedly saying that okay, this is how the trend is, right? So there's no much variability in this. Getting that? So that's how we try to read this graph. Any questions, guys? Please do let me know. Okay. Okay, so we have in this certain good hyperparameters available. So we have something called as jitter. So jitter, and then we have CI. So CI is nothing but confidence interval. So as soon as we made it as none, so you see we saw that this shaded region is now gone. Okay, so we made it as none. The shaded region is gone. Okay. Now jitter. So jitter is to make the graph more, I would say, readable. So here you can see this. Now this trend line is not touching the actual below point, and here it was touching. So we are trying to make this graph more readable. We're adding the jitters, more dots in this. Okay. So this is what is again more option we have in jitter. So we can you can always further fine tune this. We can always look the difference if a part is jitter as 0.1 or 1, and then 1 or 2 or 3. So you can see what the difference is. You can try this at your home also, right? Cool. So moving to the next, which is LM plot. So LM plot is nothing but an advanced part of my reg plot. So LM plot, the advantage here we have is the argument of call. Okay, so we can pass the argument call here. So the same trend line can be further subplotted into each of my subcategories if I'm passing it over argument call as call, right? Now I can have it in form of multiple subgraphs. Okay, so multiple subgraphs is pretty much possible here. So that's what we have when we do in LM plot, and this feature is not available in factor plot. In rect plot. Cool, guys. Any concerns? Any questions anybody is having? Is this making sense to everybody? Just a quick yes or no in the chat, guys. Okay, so I think it should be good. So almost the last category of plot which we have is a heat map. Okay, so you might have heard heat map. So heat map is again a very good graph which is giving us the correlation study. Okay, so ultimately, see, we are trying to have the interactive study, interaction between my individual variables, right? So how strongly my variables are interacting within each other. So that's what we're trying to identify. So heat map is nothing but is a two-dimensional graphical representation of data where the individual values are contained in a matrix are represented as color. So here the individual values, whatever we're trying to plot on a heat map, generally which is nothing but your correlation data, right? So here we're trying to plot this information in terms of colors. Okay, only the colors. I'll show you how exactly we do that. Okay. So now we have loaded one data set called as flights. Okay, so this is what, and we have created the data, we have pivoted the information. So here what we're trying to see is, so for each of my year, okay, and for each of my month, what is the number of passengers? So it means that for January 1949, 112. For January 1950, so for each year, you can see this that the number of passengers are increasing every month, right? And likewise for February, for March, for April, June, July. So all of these months, respective years, what is the number of passengers on the flights, right? So that's what the data is talking about, right? Now what we're trying to do is we are just simply passing the heat map, calling the heat map on the data flights here. Okay, calling the heat map on the data flights. That's what we're trying to do here. Okay. And now individually on this flights, what will happen? Now look at this information. So can you see this? The only information which you can see in this graph is the colors, right? So you can only see the colors, nothing else. So the only intuition from this graph is the colors, right? So now what is happening in these colors and how you can identify this information. So now you can see this, wherever you can see this value, right? So from here, the dark red is my lower point, 200, then the color range is increasing. So 600 means cooler, 600 means the higher value, right? So you can see this very less value, and then it is increasing towards blue, then it is increasing towards blue, right? So shades ranging from red to blue. That I've used the C map as red blue or the color mapping as red blue. It's nothing but my palette option, right? So that's what we're trying to do here, right? And we are seeing how the values are changing, and only information which I could see from this graph is the colors, and based on these colors I'm trying to intuit figure out how the data is behaving, right? Also we can see that somehow there is no still to make this graph more readable, I can have one more option called as line widths. So we have an argument called as hyperparameter called as line widths. So if you provide the line widths, it will be segregating it based on one of the the lines in between. So it'll give the clear distinction of each of my data points, right? So now I can clearly see, okay, 1949 is this square, then 1950 is this square, likewise 1960 is this square. So now the squares are pretty much visible, distinct. I'm giving a line width, right? So whatever hyperparameter I give here. And also I've used the mapping as greens. So as I said, right, so we need to identify when to choose which color map. So here we are trying to identify the shades of green. So how my data is changing is more of a comparative analysis, more of a comparative comparison. So how the increase and decrease in, right? So we use the shades of data, the greens, the grays, the blues, right? That's the more ideal scenario here, right? So that's what I've used the greens, and I could see, okay, the darker the green, the more the value, right? So darker the green, more the value. That's pretty much what heat map is, right? And also heat map is very much useful to plot the correlations. So what is a correlation? So as you know, so correlation is nothing but how my individual variables are related to each other, right? So my variable 1, how the variable 1 is related to variable 2. That's what I'm trying to identify in this case, right? So here in statistics, we also calculate this. This interaction is also has a formula in the background. So maybe we'll cover in our data science live course, which is starting in 9th of April. So you know that. So we have a live course starting from 9th of April, which is a pretty much dedicated data science course spread over 20 weekends, right? So 10 weekends, 20 classes. So and approximately 2 to 3 hours per class. So that's going to be a long class. So I will be spending roughly 40 to 60 hours to learn the right key skills and techniques. That's pretty much the objective is, right? And that is where we'll be studying all of these concepts. So the function CORR, or the correlation function, is where you will be running that formula in the background, and you'll be calculating how exactly my individual individual variables are interacting with each other. Okay, so this correlation function, the values here, it ranges from -1 to 1. Okay, so the correlation value, the range of this value, it is from -1 to +1. Okay, so -1 means highest negative correlation. That means if my variable 1 is increasing, then variable 2 is decreasing. It's an inverse correlation. If my variable 1 is increasing, then it is variable 2 is decreasing. Now +1 means highest positive correlation. Okay, so that means that if my one variable is increasing, my second variable is also increasing. It's a direct correlation. Okay, that's what we have. Also 0. If the value is 0, closer to 0, that means that neutral. There is no neutral correlation. There is no correlation. Okay. So now here you can see the entire value will be between -1 to +1. That's what the range of correlation value would be. Okay. So -1 here. So here 1 means the highest correlation, and we are doing total with total, right? So obviously we'll be having 1. So closer the value to 1 means higher the positive correlation, and again closer the value to -1 means higher the negative correlation, right? So here you can see 0.7326, it's a strong positive correlation. Again 0.85, it's a very strong positive correlation, and in fact even stronger 0.95, even stronger positive correlation values, right? So number of previous with my total spending is highly correlated. So if as long as my number of previous will increase, my total will also increase. It's a very direct highly correlation. Okay. Likewise, the negative correlation, you can see this. For example, here I don't see a very strong negative correlation. The maximum is -0.19, I saw somewhere. Yeah, so this -0.19, so this is the maximum negative correlation. So if I increase my innings premium, my total will decrease, and not by a strong value, but this will decrease, right? Now same thing, so I'm going to plot a heat map for this correlation. Okay, now you can see this here, and I put N naught is equal to 2. That means that I'm also plotting the number here. I'm also exactly plotting the number here, right? So darker the shade means stronger the correlation, and lighter the value means so here means this the negative ones are given in yellows and the positive ones are given in blues, right? So we have a clear distinction. Cool, that's pretty much what heat map says. Any questions on heat map, guys? Is heat map clear? Heat map is a very interesting graph, and I would say one of the important graphs we have in Seaborn, and it's very much commonly used while plotting the interaction study, right? So any questions, anybody is having any questions of whatsoever we have discussed so far? We are trying to cover the concepts a bit fast, and then will be closing Seaborn today anyway, right? So if anybody is having any concerns, you're not able to understand the topic, please do let me know. I'm giving you maybe 30 seconds of break. If anyway you're not able to understand, just do let me know, guys. I'm monitoring the chat. If any questions, I'll be more than happy to take it. Okay. Okay, so then in that case, moving ahead, we have a last set of graph available called as pair plot. Okay, so now what does a pair plot do? Okay, so I think we have already covered this pair plot before. I think we did, right? So pair plot, yeah, I think this was the one. Yeah, so I think we have already covered pair plot before, right? So I think we have already covered pair plot. So I think we are pretty much done with this. So pair plot is nothing but we have the all the different set of interaction being plotted under a single graph itself. So facet grid option we have here, right? So this is pretty much what we have in Seaborn, guys. So we have covered the Seaborn thing, and okay. So just to give you a recap, I'll just take 10 more minutes and I'll quickly revise whatever we have studied so far in Seaborn. We have finished Seaborn, guys. We have finished all the set of potential available graphs we have in Seaborn, and this is what we have. Again, as I've always said, plotting the graph itself alone will not help. You have to understand now, after plotting the graph, how to read this graph, how to take out the information from this so that the business can be benefited. This is what the end objective is, right? So try to make sure that whatever you have implemented, whatever you have done, you are also using it for the business benefit. So try to read the graph now, okay? But again, just giving you a quick recap. So for very first thing, we discuss about the aesthetics. So aesthetics, you have three things. You have styling, you have the scaling, and then you have the colors. So in the styling, you have what? You have the function called as set style. So we're going to use the function set style. In this, we'll be changing the themes and the axis style. So in the axis style also, we have multiple options. We observe that. So we have the colors. We can change the colors. We can change the lines. We can change whatever we want, right? So we also saw how we can change the background theme and the colors and everything. So all the styling part is on the graph is done on set style function, okay? The next is scaling, which is done on set context. So set context function is used for scaling. We have default 4 options: paper, notebook, talk, and poster. So in this case, we'll be scaling out my X and the Y axis. So it kind of, again, retune the graph, make it more readable depending on the data. But remember, it is not changing the data point. It is just changing the feel of my data, okay? That's what my set context does. And then the colors. So colors, we have the function called as color palette. So it does the color palette where we can choose a color palette. And then we have the function called as set palette. So we can call the function set palette, which is actually setting me the exact palette which I want to, or the color panel which you want to choose. So that's part from your aesthetics, okay? Then we moved in the univariate analysis. We have only single graph here called as histogram, and for this we call the function dist plot. So dist plot is nothing but is giving me a single variable distribution of my data, right? So now whether the distribution is a normal distribution like a bell curve or a zigzag kind of a graph. So that's what you try to observe from a histogram, right? Or a distribution plots. Cool. Now in the bivariate, we started with the 2 variable plots, the joint plot. So joint plot itself has 3 different varieties, 3 different flavors. So either we can use it through a default scatter plot. So it's like nothing but in the middle we have a scatter plot, and on top and the right we have the univariate graphs. Or we can have it in the form of a hex bin. So in this we'll be seeing the density. So scatter plot is giving me the sparsity. Hex bin is giving me the density where the values are more, and the third is again my KDE plot. Again, it's giving me the density only, but in a different format. Okay, so we have 3 types in joint plot. How we can change it? Using the argument called as kind. Okay, so if you give kind as my hex, or if you give my kind as my KDE, you're gonna get different graphs, and the default is scatter here. Okay, that's what a joint plot does. Then we have a relation plot. Relation plot is also the same thing here. So we are plotting, again we have an option of kind, and so there were 2 options here. We have scatter and line. Okay, so in the rel plot. So if we give scatter here, we're gonna see the sparsity of my data, and if we give line, we're gonna see how the trend of my data behaves. So 2 different things in rel plot. Okay, and then we observe very interestingly very strong 2 hyperparameters called as hue and call. Hue is adding the 3rd dimension. Call is adding the another 3rd or the 4th dimension, but also giving an extension of facet grid. It is giving me to a freedom, giving me the power to have the subgraph available within the 3rd or the 4th dimension added, right? So for example here, remember, so we added this facet grid kind of a thing, which is coming through the argument called as call. Okay, that's what it does. Now we discuss about the pair plot. So pair plot, it is giving me the interaction of all the possible combinations of my numerical data we have, right? So all the possible combinations, so all the possible combination of graph will be plotted in a single graph. Okay, it'll bifurcate into multiple subgraphs, but this entire is one single image. Okay, it's a one single object, one single image object, which is being shown here. Okay, and in this we also have two arguments. We have diagonal kind and we have the normal kind. So diagonal kind means it's the diagonal graph, the univariate graph. We can have it as a KDE or a bar, whatever I want. And also this, the bivariate graph, we can have it as a scatter or line, whatever I want. It's pretty much possible. Okay, so this is what we have in pair plot. Then we started discussing about the categorical data. That's where we have strip plot, swarm plot, box plot, violin plot, and everything, right? So we started with strip and swarm. So strip and swarm are almost same. The only difference between strip and swarm is giving you the exact point. So we can count the exact number of observation in swarm plot, but also giving me the kind of feeling of density. So like where the maximum number of data points are available. But in strip plot, you are getting kind of a overlapping of my dots. So it's not very clear in this case. Now move to box plot. Box plot is giving me a very good information of my data spread, right? So how my data distribution is per category. So how my data values are distributed per category. It's more of a categorical to numeric interaction, right? So numeric value is here. So we have a petal length numeric value, and the categorical value is my species. So categorical to numeric per category, how my petal length distribution is for the data, right? So the data distribution is what is happening through my petal length. That's what it's coming here, okay? Likewise, we have something called as violin plot. So violin plot is also giving the same information with an added advantage. So violin plot is giving me two things. Giving me first the data distribution for sure. It is giving me the data distribution, and the second is also giving me the density, right? So you can see this. So here I have a bulge part, right? So density here. This is giving me that okay, in this area the values are more. The number of data points in this smaller region is more. That's what violin is giving me. So box plot is only giving me the data distribution, while violin plot is giving me both the data distribution plus the density. Okay. Then we move with the bar plot. So bar plot is nothing but is again giving me the information of how a particular categorical data is kind of distributed in terms of whatever numeric value we have. Okay, so categorical information in terms of my the values here. Then extension to that is count plot. So count plot here on a single category we are finding out how exactly my data is distributed. So what is the exact number of counts of each of my different subclasses. Okay, so the exact count of my data, right? And also we can also in the graph itself we can add those number by using the function called as bar label. So this bar label is available in the latest Seaborn, not available in the previous version of Seaborn. It is only available in the latest version. Okay, so if we simply call bar label and use the available containers, the data is already available. It's going to plot the numbers also. Okay. So we can also add hue. Hue is nothing but again adding a third dimension. We can always do that. Now moving to the point plot. Point plot is giving me the relational study between my categorical to numerical graph. Okay, so giving me the relational study. So here I can compare. So between each of the subclasses, how the data points are behaving. So the central value or the average value of male is somewhere around 0.1. But for the female is 0.4, right? So we have a drastic steep increase, and then in this steepness is even further for the second class, and the steepness is lesser in the third class. The graph is more steep in the second class, right? I can see there's a very sharp steep in between male to female comparison, right? That's what point plot is giving. It's a referential study. It's a comparison kind of a thing which we can do in point plot. Okay, so on the same of the point plot, factor plot is also giving me the same thing. It's similar to what point plot does with an extension of facet grid. And what is the facet grid? We have a hyperparameter call which can be provided in factor plot, which cannot be provided on point plot, right? So we saw that. So here, as you know, so on the factor plot, we can give the argument which is call, and if we give call, we can have multiple subgraphs here. You can see this multiple subgraphs. This is possible in factor plot, not in point plot. Okay, then we proceeded with the linear relationships. We have two options, reg plot and LM plot. Again the same thing, reg plot and LM plot are almost the same thing, but LM plot is again having an extension of facet grid. So LM plot has facet grid, that means it has an option of argument call, COL can be passed in LM plot. But what is these? So they are in the scatter plot itself, they are passing a trend line. So this trend line is giving me the kind of interaction. So how the two variables x and y are interacting. What is the correlation? The relationships, the linear relationship is being plotted here. Okay. So on the rect plot, as I said, so lm plot, we have an option of call. So once I pass this, for each of my subgraphs, we'll have a separate trend line available. So that's what lm plot does. Okay. At last, we had the heat map. So heat map is nothing but giving me the information only based on colors. So only based on colors, we are identifying how the data is behaving. So remember, so we have option called as line widths. If we're going to give line widths, making the graph more readable. So here we have used the C map as greens, color map as green. So darker the shade, darker the value, lighter the shade, lesser the value, right? So I can see this. Okay, now in this month, so it is increasing. So it is, the shades are increasing from lighter to darker, right? So we can see a gradual increase in the values every year, every month also, right? So that's what heat map is giving you, right? That's a very quick recap to whatever we have studied so far, guys. I hope it is making sense, right? This is what we have in Seaborn. We are pretty much done. And we have covered all the graphs which is possible in Seaborn, right? So we have covered all the graphs in Seaborn. This is what we have, right? So this is pretty much it from Seaborn, guys. If anybody is having any questions on anything whatsoever we have discussed so far, please do let me know, or else I think we are pretty much good for today. And I wish you happy Holi, and thank you so much for joining us. Please have a safe and a sound Holi, colorful Holi with your friends and family. So tomorrow we will not be having any class on the occasion of the festival. So we'll not be having any class tomorrow. We'll be going live again on day after tomorrow, same time, 10 p.m. So let's join again on the same time, 10 p.m. from day after tomorrow. There'll be no class for tomorrow. But again, guys, remember we have a data science live class starting from 9th of April. So do not forget that. Please do go to the website and try to look out for data science live course starting from 9th of April. I'll be taking you that on that course, and we'll be pretty much doing all the latest tools and tech required to kick off your data science journey, right? So do look for the syllabus, and we are kicking off this class from 9th of April. So do register yourself for the class, guys. So with this, I'm going to take a pause and bring your evening back. So enjoy with your family, have a safe Holi tomorrow, and we'll meet again on day after tomorrow, but that is Saturday. So we'll not have any class tomorrow on Friday. So we'll meet on Saturday. Okay. So with a new topic, pandas. So we'll be starting from pandas on Saturday. Cool. Thank you so much, guys. Bye bye.